Good afternoon, class. Am I audible? Am I audible? Is my screen visible? Okay. So, last lecture basically we have started with chapter number 5. We have covered basic scenario regarding interaction diagram. In interaction diagram, we have covered on we have covered on sequence diagram. Then we have discussed collaboration diagram. Then we have discussed what is the use of sequence diagram, what is the use of collaboration diagram, then what is the normal procedure to draw the sequence diagram, normal procedure to draw the collaboration diagram, and then we have discussed two case studies. Basically, one is from the banking side and one is I assign you to open an account. Considering that particular use case, I have assigned the task to you as a part of what we can say tutorial 6 to draw and an sequence and collaboration diagram for banking system, especially considering the scenario for opening and saving account. I hope all of you have done with this. Any doubt regarding yesterday's session, that is regarding sequence diagram, collaboration diagram? Because in dynamic behavior we have completed activity diagram and state chart diagram also. So if we see, whenever we are talking about the dynamic behavior, we need to understand activity diagram, we need to understand then sequence diagram, and from sequence diagram you can convert the sequence diagram into collaboration diagram, and after collaboration diagram you can draw state chart diagram. So if you take example of these four types of a diagrams, these four types of a diagram, that is activity diagram, sequence diagram, collaboration diagram, and state chart diagram, these four diagrams will help us to understand the behavior. So that behavior will, how your system is going to act and react. Simply how system means project, whatever you are going to do, how system will behave. We'll talk about the behavior, how system will, simply we can say act, react based on the dynamic behavior. So these four diagrams you need to understand. Once you are aware about these four different types of diagrams, means not only the conceptual part but in the practical perspectives, in the practical scenarios, how to draw and how to complete this scenario, you can able to understand the entire dynamic scenario of the system. So I hope this part is clear to you. Any doubt regarding this part, dynamic behavior of the system? If any doubt, any query, any question, let me know, or else we can start with our 6th unit, that is the last unit, architectural modeling using UML. So if any query there, let me know, or else shall we start with the unit 6? Reply something, yes, no. Yes, any reply there? Okay, Omkar. So we are continuing with the next chapter, that is architectural modeling using UML. So as the name suggests, architectural modeling. Now, what is the main idea behind this chapter? Because before starting with this chapter, we have covered the what we can say static part, that is static modeling, and recently we have seen the dynamic modeling. Now, understanding this static part and dynamic part, when we are combining this, that we are going to call as an architectural modeling. Understand what I'm saying? So first part, if you remembering, before starting with the dynamic behavior, we have completed the static part. If you are remembering, we have completed the static part. In static part, what we shown? We shown use case diagram, we shown class diagram. It is expected to have object diagram before. We have shown object diagram, then we have shown the class diagram. These are telling us about the static part. These are telling us the dynamic behavior or dynamic part of the system. So combining static part and dynamic part will help us a lot to understand the architectural scenario of the project. Understand this? I'm talking about the first as a static part, second as a dynamic part. Okay, so this use case diagram, object diagram, class diagram will talk about the system or the project what on which you are working, how they will look, means their scenarios will be discussed inside this use case diagrams. But what input they have entered based on their scenario part, it is going to start with as a activity diagram, where we have discussed the flowchart, sequence diagram, the interaction among the objects, and then state chart, means type of input you have, and with respect to input, what will be the next state. These parts in detail we have discussed in the dynamic behavior. Now we are discussing about the architectural dynamic, or we can say architectural modeling. Now understand, in case of architectural modeling, we will discuss whatever we have prepared as a part of a static part as a dynamic part, our project will be ready. Because when you complete your class diagram, you can able to have the code. Once the coding part is done, means your product development is done. Now which product you have developed, you need to organize the product. Whatever the project you have done, you need to organize your project in terms of, we can say, packages. And that packages, whatever the different packages you will prepare, because project is nothing but group of, simply we can say it will be represented in terms of a packages. So inside the packages we may have a different parts. So that different part may be called as what? Packages, then subsystem part, and we may have one more part over called as what? Component. In previous lecture also we have discussed the basic idea about the packages, subsystem, and component. I will just quickly revise. Package, I have taken the simple example for the packages. Microsoft Office will be considered as a one package. Microsoft Office. Suppose I'm looking for version 2010. Just for the understanding, I'm considering this in the as a form of an example. Then this Microsoft Office package made up of different subsystems. So what are that subsystems? We can say that I have like power slide presentation. I have like .doc, docx basically, pptx also. So these are subsystems, means they have a separate behavior. See, this is my Word file which I am working on it. This is what my power slide presentations on which I am working. These all are parts of my Microsoft Office package. So this will be considered as one system. And inside that system, inside that package, I have a different subsystem. Now what is component in that example? Component is the most, what we can say, the mostly used reusable part of the system, which can be easily replaced. Means I can here simply I can copy the part, I can paste it anywhere. Suppose I'm copying it from power slide presentation and I'm pasting it inside my Microsoft Word document, but still it is allowing me. So this is simply a copy paste option like this. Means irrespective of type, whatever the type, it supports a lots of heterogeneity. Even it supports complete dynamic simulations. So I'm calling this simply as a component part. So what does the component mean? It is a part of a subsystem which can be working independently and without depending on the underlying behavior. It supports the entire scenario. I'm calling this as a simply component. In detail we have discussed. So understand, packages, just a group of similar things together, we'll call it as a package. Now what is subsystem? Subsystem is nothing but a part of a packages which has a specific behavior. We will call it as one subsystem. And component is a part of a subsystem but which will behave independently than underlying scenarios. Subsystem has a dependent behavior, whereas component does not have a dependent behavior. They work inherently, they work independently apart from the system scenario. We will call them as one component. So understand, that is as a main difference. Is this clear? Okay. Now, in case of this architectural modeling part, what we are going to discuss? We are just going to discuss that my project is ready. I have a packages. Depending on the packages, I have organized them into the system. So project made up of different packages, subsystems, and components. So which package I'm going to put where? Suppose I want to decide, I want to take a decision, I want to decide which package to keep where. I just want to take a decision which package I want to store, at what location I can store. These all the things I need to take into the consideration. So while you are working with these considerations, you need to think about the model called as what? Architectural modeling using UML. So in architectural modeling, we are simply going to take the decision whether in my project, how many packages are there, which package I'm going to store. Means where to store means, suppose I have a client. So at what I will keep at a client side, I have a server. So what I'm going to, which package I'm going to keep at a server, or whether I am going to consider that package as a subsystem or as a component. So I need to take the decision which component I'm going to decide. So normally we can say we have three scenarios. One is an application scenario, one is an operating system scenario. So simply what we can say as a part, we can say that is as the user side. So we have a user side, we have server side. So which part you are going to keep at a user side, or which part you are going to keep at a server side. So based on that, what we can say simply as a user view, then you can have system view. That system view I can say simply as operating system view, as a OS view, and I have one more view that is as a backend side. So this is simply as a backend part I can say for understanding purpose. So which package you are going to keep at what level and how you are going to provide a connections among them. This part we'll discuss about the chapter number 6 called as what? Simply we can say this simply as an architectural modeling. So what are the points we are going to discuss? We will discuss what is component, we'll understand the concept of the deployments. So deployment, what does the deployment? So deployment is nothing but the deploy parts. Now as the name suggests, deployments, what we can say simply, as you are aware about the software development life cycle, it is made up of analysis. After analysis we can have design, After design, we can have coding part, and after coding, we can perform testing. If test product is okay, after testing, if the product is ready, after testing, if product is ready, we can deploy the product. Means we can deploy the products. Means we can simply hand over product to end user. Means what is meaning of deploy? Means what I said, it is just to simply hand over the product to end user. Means we can simply say deploy is nothing but install. For my simplicity, for my understanding, what I am saying, the deploy I will call simply as a install. So only after the install, means you can install the product at user side. So your user, whoever your expected end user is there, so end user will start using your product. So that end product will help us to understand the scenario regarding what we can say. Sorry. Okay. So this is just simply hand over the product to end user, and user will start using the product. So that process we call simply as a deployment. And the one who are going to install the product, or who else is going to hand over the product to end user, that team we are calling as what? Deployment team. Sometimes it is called as what? Support also. So they are going to provide support to end user. So in might be the case that your family members or your senior friends in which you are in contact, they are saying that I'm going to out of India. On basically what they are going to do, they will go to their locations. End users or the company have a separate office over there, and they will be going there to support their tasks, to carry out the scenarios. And based on that type of a scenarios, they will carry out some work related to that. So we are calling them as a part of a deployment team. So I hope you are clear with the concept called as what? Deployment. So deployment is nothing but, can anyone tell me what is deployment? Yes, anyone? Whatever the part we have discussed so far, what is the deployment? It is nothing but simply the person who will be responsible to install the product at the user end user side, and based on that scenario, they will work at either end side or either at user side. So it will be decided by the working scenario. Is this part clear? Okay. So we will discuss the deployment concept, and after the deployment concept, we will try to understand the collaboration work related to this. Then some patterns. Pattern means common solutions. So pattern and frameworks. These are the solutions. So considered as a common solutions for the given problems. We will call them as what? Pattern. So in our Swery family, we always used to follow one word called as what? Swery pattern. Now what does this Swery pattern means? We have some common methodologies to solve the problems. That is what we solved many teaching related problems or teaching learning related problems by understanding or by deploying, by implementing. So one more word for the deployment is what we can say, implementation. So it is one kind of a way, approach will help us to solve the common regular problems, and the method through which we are calling it, we are calling as that one? Pattern. So pattern and the frameworks, and then we will discuss how to complete the component diagram and how to complete the deployment diagram. The part is very simple. The syllabus for this particular chapter is very small one, but very good subject. So outcome, mostly the part what we will discuss in this chapter is how to draw the component diagram and how to draw the deployment diagram. These two most important parts we are going to discuss. So let us understand this. What is component? uh, what we are going to see as a part of architectural modeling. So architectural modeling is nothing but what we can say simply an architecture is a set of significant decisions about the organizations of the software system. It guides us about the elements, their interfaces, their collaborations, and their compositions. Architecture can be defined at both logical and physical level. So logical architecture, it shows more generic view of the architecture, whereas the physical architecture will describe in detail how the software systems are going to get designed. So architectural modeling will tell us the basic idea which product we are going to deploy at what level. So level, just now I just discussed about the levels, maybe users level, maybe at a system level, or maybe at a backend level. So you need to understand which part of your project that you will deploy at what level. So that understanding and that representing in, we will call it as what, simply an architectural modeling. So let us discuss it with the simplest part called as what, component. Because in the project scenario, each and everything, whatever we have discussed so far, will be discussed in terms of the components. Because component, everyone will try to have their product with respect to the component scenario. And in the component scenario, we will try to see how my product look likes, because component is the mostly reused part of your project. So I will try to develop, means as a developer's perspective or as a business perspective, what I want to say is, whatever the part you will develop, try to develop the product in the simplest manner. And component is one of the mostly used part to understand the product scenario. So I will call this simply as a component. And once I could able to find out the component, I can organize the component at what different levels. So I'm calling this as a component diagram. So let's understand the diagram first, and then we will discuss the various parts. So component diagrams are used to visualize the organization and the relationship among the components in a system. So these diagrams are also used to make executable system. So most important part is component is an executable part of the system. Component diagram can also be described as a static implementation view of the system. Static implementation that represents organization of the components at particular moment. So I will just draw a simple diagram. So what we can say, mostly when you see a blueprint of any building, when civil engineer shows us that blueprints, so looking towards the blueprint, we can able to understand where my door will be there, through which I can go for in out, window. So that part tells us about the components, because these are the different components like doors, the windows. And if you want to change their positions, you can change accordingly, and that you can represent. So that is what I am showing as simple as a component part. So single component diagram cannot represent the entire system, but based on the type of view or the type of the perspective, we can have a different component diagram. So let us understand the purpose of the component diagram. So just quickly go through this. So sorry. So let us see the purpose of the component diagram. First, it will help us to visualize the components of the system. So just looking towards this, we can understand how many different components are there in my system, and how I can able to put the different components at different levels. Second part is construct executable by using forward and reverse engineering methods. So in previous lecture, we have seen the concept of forward engineering. Forward engineering means you have a class diagram and you can convert the class diagram into an executable code. So that I'm calling as one concept of forward engineering. And reverse engineering means you already have a code with you and you can try to convert that code into the diagram part. Means sorry, if you make a changes in the code which will allow you to make the subsequent changes in your diagram part, that process we can discuss as a part of reverse engineering. Next, it will help us to describe the organization and relationship of the component. So component diagram will help us to understand which the entire scenario. Just like example, I will continue with the same example. If you look towards the blueprint of the bungalow or the blueprint of the house, so which will tell us how many doors will be there, how many windows will be there. If is it possible for me to change the window depending on the sunlight or depending on the flow of the air, so that I can utilize maximum natural resources. So that type of decisions can be taken very easily when you have a diagrams with you before going for actual construction. That actual construction will be the part of your deployment, but component will tell us how many elements will be there. So that is what the use of component diagram. So in detail we will discuss it again. So component diagrams are one of the two kinds of diagrams found in the modeling, that is what physical and logical perspective, and I'm calling as simply object oriented scenarios. It shows the organization and dependencies among the set of the different components. Like door, based on the door position, window will be decided, or based on the type of a window, the length of the window, you can decide the doors. Like that, just for the simplicity I'm telling this. So it shows the what we can say high level reusable part of the systems are represented in the component diagram. So most important part is reusable part of the system. We will call it as one components rather than system subsystems. It will visualize the static aspect of the physical component and their relationship to specify their details for the construction. So collecting various executable libraries, files, tables will build a simple component diagram. So we will see a few examples and then we will come to understand the component diagram. So whenever if I'm planning to go for the component diagram, I need to understand the component. I need to understand the concept of interface. Then I need to understand the concept of ports. And once we got this idea, we can able to have the connectors. So simple idea is what I can say. To understand the concept of component diagrams and deployment diagrams, we need to understand, or we need to work with a software scenario in the networking perspectives. So mostly networking elements that we are going to configure through the present network or through the new network, to configure the elements, how the way, the style you are carrying out, etc., will be discussed as a part of the component diagram. So let's see each one of them one by one. So what is component? Just a second. हाँ मला आज सकाळी फाईन झालाय येताना. होय, 100 रुपीज घेतले त्यांनी, पण आलेच किती. ओके, थँक्यू. Sorry, just got interrupted. I'm discussing about the elements of the component diagram. So what else will be there to draw the component diagrams? So we need to understand the concept of components. So what the components are made up of one or more classes and describe the part of an application that can be assembled and reused. Defined as physical replaceable part that conforms to and provide the realization of set of interfaces. So graphically, component is rendered as a rectangle with a tabs with the name of object in it preceded by a colon underline. So this is just a notation to represent the component. These are the two tabs, a rectangle with the two tabs. We'll talk about the component. Basic definition of the component is, now I can conclude, is a component is most reusable and replaceable part of the system. So if something goes wrong, you can easily replace it. So most reusable and replaceable part of the system, I will call it as one component. So if I take an example of my mobile phone, inside my mobile phone, I have a different subsystems like battery, softwares, different hardwares. So I can replace mostly replaceable part and reusable part of the system called as what? SIM card. Because if I have a Samsung phone, for example, and I have one more phone with me that is from a different manufacturer, let us see, one is a Samsung, one is Oppo. So I cannot change their batteries, but most replaceable and reusable part of my system, which I can easily change from Samsung phone to Oppo phone, is only the SIM card. So that SIM card I will consider simply as one of the best example to understand the components. So components are what? A physical replaceable part that conforms to and provides the realization of set of interfaces. Now this realization means real-time implementation, and a set of interface means whatever the properties are defined, that properties will be implemented, with the help of the system behavior. So that system behavior will help us to understand the entire scenario, that I am calling simply as a components. So I hope the definition of the component is clear. Yes, anyone? Simply remember what is component. Component is a system's part which will be easily reusable, which will be replaceable, and if get replaced can help us to implement whatever the part is decided for understanding scenario. So I hope this part is clear. What is the deployment? This part is clear. Okay, after this we can discuss the next concept called as what? Interface. Now what is the interface? As the name suggests, remember interface is nothing but uh, what we can say, it is a simply plug and play architecture. You come, you fulfill your purpose and then leave the connection. So I'm calling this simple as an interface. So in technical language is what we can say. You might have seen in Java, or you might have seen in a few cases of C++ also. So interface is nothing but it is just a platform where different components come together and they share. It is just a media, or it is just a platform through which they can able to interchange some properties by sending the messages and receiving the messages. So interface, it is just a simple collection of operations that are used to specify service of class or components. It is displayed as a circle. This is a one way, or you can replace it in terms of a rectangle with stereotype notation. So this is the standard notation. This is the standard notation to represent the interface, and this is additional notation in terms of what we can say stereotype notations. So it is displayed as a simple circle or a typical class with a stereotype of interface. So you can represent interface either with this style or with this style. Both style will be accepted. Mostly use this simple rectangle. Again, there are different types of interfaces. So provided interface and a required interface. So this is will be an additional part and this will be an compulsory part. Simply I can say this. So provided interface, an interface that the component provides as a service to other components. So they will just help us to carry out the behavior or just to carry out the operations of other systems just as an part, just as a media. So I'm calling it as what provided interface. So this component will provide the services to other components to carry out their work. So provided interface. Required interface means this particular component is intended to carry out these particular operations. But to carry out the particular expected operations, it need the help from other components called as what required interface. Means you have a SIM. So just by taking the SIM, is it possible to make a call? No, you have to insert that SIM into a mobile phone. Getting? So that is what the required interface. And once you have the required interface over there, you have a SIM card with you. Just by activating one internet service on, you can use the internet on your mobile. That is what provided interface. Is this clear? Okay. Then we can discuss the relationship between component and interface. Now this part is very, very important to work out with the scenario. So this is elegant iconic form we can represent. So provided interface is shown as the circle attached to the component by a line and a lollipop. This is the simple notations. A required interface is shown as the semicircle attached to the component by a line and a socket. In both cases, the name of the interface is placed next to the symbol. So this is provided interface. This is the required interface. So this is L order services. This is weather forecast. You can understand. So see the example. Okay. This is expanded form. The same thing in technical scenario, they will be represented with this as an expanded form. The next part is called as what? Port concept. So what we discussed so far, we are discussing about component diagram. But to draw the component diagram, we need different elements. So what are the elements we need? We need component, we need interfaces, then we need different ports, and then we need different connectors. So we are discussing the first part called as what? Components. So hope you are clear with the idea. Components are nothing but which is a replaceable part of the system, mostly reusable part of the system. We will call them simply as a component. How to represent the component? A simple rectangle having the two tabs. We will call this simply as a component. So this is the component. The naming convention, this is the naming conventions what we can give is, for example, this is the component working in the file, working in the scenario of admission. So I'm calling this as a library files. Then we have discussed interface. What is interface? So interface is nothing but a simply plug and play architecture. It is just as a platform which will help us for the implementation of the component scenario. So basically there are two different types of interfaces. One is a provided interface and one is required interface. So provided interface means whatever the scenario you have will be helping us to carry out few other services which are helping us or which help us to other components to complete their work, we'll call them as a provided interface. And in case of a required interface, the interface that component conforms to when requesting services from other components, we will call them as a required interface. Simple example is what I said to you. Most in what we can say, most able to understand the concept of a component, simply remember the SIM card. You can easily replace the SIM card from one device to another devices independently. It works. So we will call this simply as a part of a component. So components are most easily replaceable, reusable part of the system. So to once you have a SIM card with you, you just need to insert into a specific device. Now to work with a SIM card, you need a device, that is a required interface. And once you have a proper required interface, once the SIM card is inserted in the mobile, you can making a phone calls. So along with making a phone call, suppose you want to activate internet, just go and just go in the user interface and start an internet services. So that is what provided services. One interface will help us to carry out other operations like internet, video call, then video messages, like that. So simply I call this as a part of a provided interface. So this is types of interface you can discuss. Simple notations. This is a solid rectangle. This is dashed. I'm calling it as what? Required interface. This is provided interface. This simply talks about the dependency. So L order service, user interface. This is a weather service, one component. Different components can interact with each other. That interactions I'm discussing as an interface. Is this clear? Okay. Next part we will discuss as a port, but that part we will discuss in the next lecture. I'll complete the attendance part first. Okay. So give your attendance. Roll number 1. Roll number 1. 2. Your
Present,
attendance.
sir.
2 is present. Okay. 3.
Present, sir.
4.
4 present, sir.
5. 6.
Present.
7.
7 present, sir.
8.
Present.
9. 10.
Present.
10 present. Okay. 11.
Present, sir.
12. 13.
Present, sir.
14.
Present.
15.
Present, sir.
16.
Present, sir.
17.
Present, sir.
Sir.
18.
Sir.
19.
18 present, sir.
19.
Present, sir.
20. 21. 22. 23.
23 present, sir.
24.
Yes, sir.
25.
25 present, sir.
26.
26 present, sir.
27.
27 present, sir.
28.
28 present, sir.
29.
Yes, sir.
30.
30 present, sir. 30 present, sir.
Yes, yes.
Yeah.
Yes. $31. 32.
32 present, sir.
33. 34. 35.
35 present, sir.
36, 37,
37 present, sir.
38,
38 present, sir.
39,
39 present, sir.
40,
40 present, sir.
41,
41 present, sir.
42, 43,
43 present, sir.
44, 45, 46, 47,
47 present, sir.
48,
Present, sir.
49,
Yes, sir.
50, 51, 52, 53, 54,
Present, sir.
55, 55, 56, 57, 58, 59, 60, 61, 62, 63,
Present, sir. 63.
64, 65,
Present.
66, 67,
Present, sir.
68,
Present, sir.
69, 69, 70.
Present, sir.
Any correction there?
Sir, roll number
44
5.
present, sir. Sir,
Any other correction? Yes. Any other?
Sir, 34.
34. Any other? Okay. So we'll take a pause here. Next lecture we will discuss the remaining parts of a component scenario. Any question there? We have discussed the basic idea up to the ports regarding the component diagram. If any query there, let me know, or else we'll take a pause.
Sir,
Yes.
sir, A36 is present.
Okay, I will correct it. Okay. Hello.
Thank you, sir.
Yes.